Welcome to geometry. We want to take a look at constructions again, and in this case, construction 3, our third construction, which is the perpendicular to a line again. So it's our third example of a perpendicular, but in this case, we're looking for a perpendicular through a point that is not on the line. So really quickly here, if we have a line L and some point P, the idea is for us to first construct a circle centered at P with any radius that will get us some intersection points with the line. We call those intersection points A and B. From here, again, it's exactly the same thing as construction 1, and we construct the perpendicular bisector of AB. Very brief now, right? Which would amount to creating, marking a couple of points, and looking at the line through those. So that's what we want to do to construct the perpendicular to a line through a specified point. So for given line L and a point P not on that line, we want to find a line M through that point that's perpendicular to the given line. So again, in order to do that, we're first going to construct a circle centered at P with radius R. And that radius, of course, should be greater than 0, but it should also be large enough to get intersection points A and B. So we construct this so that way we can identify the intersection points A and B. So those are what we want to construct. And then, of course, we want to construct the line M, which is the perpendicular bisector. Use the right notation here. The perpendicular bisector of AB. So that's all that we need to do here. And for a brief justification, right, we can say that if we've done this, then we know that PA is equal to PB by the definition of a circle. But because PA is equal to PB, we know that P lies on the perpendicular bisector of AB by the perpendicular bisector theorem. So P is on the perpendicular bisector of AB by the perpendicular bisector theorem. Excellent. So draw this a little bit larger. If we have some line and some point P, we want to first construct a circle, and we just mark the relevant points. So we get a circle of some radius that's large enough to get us a couple of intersection points. We call those intersection points A and B. So again, overall, we're drawing a large circle with center P that intersects at A and B. So once we've done that, right, we just mark the points that are necessary, though, to identify, or yeah, we draw markings so we can identify the intersection points. Then from there, we do the same construction that we did for the perpendicular bisector of AB. And to do this, looks like it might be a little bit off here. Let's put that there. Small correction. Anyway, let's see. Draw a circle centered at A with radius AB. So if we wanted to draw that large circle, it would be, right, it'd be this entire circle. But we just want to mark the necessary points. So it would be somewhere around here and somewhere around here. And that might be a little bit too too far. There we go. That looks pretty good. And then circle centered at B with radius AB as well to give us these points. And then, of course, the line of interest here is the one passing through the intersections there, C and D, which passes through P as well. Excellent. So that's how we would find a perpendicular to the line L. M is perpendicular to L and it passes through P. Excellent. But that's all that we wanted for this construction. So I'll see you guys again shortly with construction 4.